All right, welcome everyone. Today we are diving straight into a hands-on workshop. And here's the philosophy. To build the strongest defenses, you absolutely have to understand the attack first. We're going to get our hands dirty with one of the most stubborn and damaging vulnerabilities out there, SQL injection. Let's get started.
It sounds like something straight out of a Hollywood hacker movie, right? How can one single tiny line of code completely bypass a login screen and just crack open an entire database for the world to see? Well, this isn't fiction. This is the very real power and the very real danger of SQL injection. And trust me, this is not just some theoretical thing we do in a lab. We're talking about massive, real-world data breaches. Companies like TalkTalk, Heartland Payment Systems, they were brought to their knees by this exact vulnerability. It all came down to a basic failure to check what users were typing in. The cost? Millions and millions of dollars in damages, not to mention millions of stolen customer records. And the craziest part, this attack is decades old, but it is still one of the top threats out there today.
So here's our mission plan for today. We'll kick things off with a quick briefing to make sure we all understand the threat. Then, the fun part, we'll build our very own lab environment. After that, we're going on the offensive with our first hack. Then we'll level up with some pro tools, learn how to build strong defenses, and finally, we'll connect the dots and see how these skills translate directly into a cybersecurity career.
Okay, first things first. We need a safe place to practice our attacks, a digital firing range, if you will. We're going to be setting up something called the Damn Vulnerable Web App, or DVWA for short. This step is absolutely critical because it gives us a controlled, legal, and ethical environment to launch real attacks without, actually breaking the law or causing any real damage. Getting this up and running is actually pretty straightforward. First, you'll want to download DVWA onto your lab machine. Something like Kali Linux or Ubuntu is perfect for this. Next, you'll need to configure your web server, which is probably Apache, and your database server, MySQL. Once those two services are humming along, you just open up your browser, go to the DVWA setup page, and hit the big button that says Create/Reset Database. But hold on, before we go any further, let's run a quick pre-flight check. First, is your Apache service actually running? How about MySQL? Seriously, if you run into any connection problems, 9 times out of 10, it's one of these two. Can you physically get to the DVWA login page in your web browser? And finally, did that database reset finish without spinning out any angry red error messages? If you can say yes to all 4, you are good to go. Okay, now for our first exercise, I want you to go into the DVWA Security tab, and you're going to set the security level all the way down to low. Now, I know, it feels wrong, right? But we're doing this on purpose. We are intentionally lowering the shields. This lets us see the raw, fundamental principles of the attack without any fancy filters or defenses getting in our way. We'll crank up the difficulty later, I promise. All right, our lab is set up. The security is dialed down to low. It is time to go on the offensive. I want you to think of this next part as a real-world simulation, a challenge. Your mission, should you choose to accept it, is to bypass the login and pull some sensitive data right out of the database. And this is the classic, the OG of SQL injection. By typing this little phrase, apostrophe or 1 equals 1, into a login field, you are basically hijacking the logic of the database query. The system is no longer just checking your password. It's asking, does a password match or is 1 equal to 1? And since 1 always equals 1, the answer is always true, the door swings wide open. It's a simple, elegant, and absolutely devastating little logic trick. Okay, so we're in. But just getting past the login isn't enough. Now we escalate. We want to steal stuff. To do that, we use a command called union. This payload basically tells the database, hey, run your normal query, but also union it with the results of my query. And our query is asking for the user and password columns from the users table. That little double dash at the end, that's just a comment. It tells the database to ignore anything that comes after it, which neatly cleans up our injection. So what are we actually stealing? It's important to know we're not usually getting plain text passwords. We're getting their hashes. Think of a hash as a unique one-way digital fingerprint of a password. You can't just reverse it to get the original password back. But what you can do is take that hash offline and use powerful tools to guess billions of passwords a second until you find the one that creates the matching fingerprint. It's the key we need for our final step. And for those of you looking for a bonus challenge, here it is. Take those hashes you just pulled from the database and feed them into a tool like Hashcat. This isn't just for fun. This is exactly what a professional penetration tester does on a real engagement. Taking those hashes and turning them back into passwords is a make or break skill, and it's a super common task on certification exams like the OSCP and CEH. Now, typing these attacks directly into a browser is a fantastic way to learn the basics. But the pros, they use some serious firepower. So let's level up and see how to launch a much more controlled and powerful attack using one of the most essential tools in any web security toolkit, Burp Suite. So here's how you get it set up. First, you tell your browser to send all of its internet traffic through Burp Suite's proxy. Then, inside Burp, you flip on the intercept button. Now, when you try to log into DVWA, Burp will catch that request in mid-air before it ever reaches the server. From there, you can send that captured request over to a tool called Repeater, and that's where the magic happens. You can tweak your SQL injection payloads, send them again and again, and see exactly how the server responds each time. And that's precisely why a tool like Burp is a game changer. It lets you pop the hood on a web request and see everything, every single header, every parameter. It gives you this incredible level of visibility and control, which makes finding and exploiting vulnerabilities like SQL injection way more precise and way more powerful than just blindly guessing in a web form. All right, we've had our fun breaking in. We've seen how fragile some systems can be. Now, let's switch hats. It's time to learn how to defend. Let's talk about how we build strong walls to stop these kinds of attacks dead in their tracks. Now, it is so important to understand that this is not some obscure, highly advanced vulnerability. SQL injection is a perennial all-star on the OSPOSP Top 10 list. That's the industry's definitive guide to the most critical web security risks. Right now, it's sitting pretty at number AO3, under the general category of injection attacks. And right here, this is it. The problem and the solution, side by side. On the left, you've got vulnerable code that just takes whatever a user types and blindly stitches it into a database query. That's a disaster waiting to happen. On the right, you have secure code. It uses something called parameterized queries, or prepared statements. This is the key. This technique creates a fundamental separation between the command and the data. It ensures that user input is always treated as just text, never as part of the command itself. This is the single most effective defense against SQL injection, period. So you might be asking yourself, if the fix is so well known, why on earth are we still seeing these attacks succeed, especially against big financial systems? Well, it almost always boils down to a few common human mistakes. Developers get rushed and they forget to validate user input. Development teams neglect to use those parameterized queries we just talked about. And sometimes whole organizations put way too much faith in a firewall, thinking it's a magic box that will solve everything, even if the code behind it is insecure. And this is where compliance frameworks really come into play. Standards like PCI DSS, that's the one that governs credit card data, and ISO 27001, they explicitly require secure coding practices. They turn it from a nice-to-have into a must-do. They make it absolutely clear that preventing vulnerabilities like SQL injection isn't a suggestion, it's a hard requirement. The defense really does start right at the developer's keyboard.
So let's bring this all home. Everything we've done today, setting up this lab, launching these attacks, and then understanding how to defend against them, these are not just abstract academic exercises. These are the absolute foundational skills you need for a professional career in cybersecurity.
This hands-on lab experience, it's basically a miniature version of the challenges you're going to face on major certification exams like the OSCP or the Certified Ethical Hacker. This is a core skill, a bread-and-butter technique for any penetration tester who needs to assess web apps and write professional reports. But more than anything, it helps you build that all-important defensive mindset. You have to learn to think like an attacker to build truly effective defenses. And that really is the heart of it, isn't it? That's the core philosophy. You just can't effectively protect a system if you don't fundamentally understand the ways an attacker will try to tear it down. The very best defenders are the ones who have spent time walking in the attacker's shoes. And that leads us to our final thought for the day. Defenders who can't think like attackers will always be one step behind. The whole point is to be proactive, not just reactive, to see the attack coming before it ever happens. That's the mindset we're trying to build here. For more hands-on explainers just like this one, make sure you're subscribed. Thanks for joining in.